This is CPM Calculus Chapter 4, number 49. So here we're asked about h of x. So we're given h of x in each problem below. Define functions f of x and g of x. So we want two functions such that h of x is equal to f of g of x. Remember, this is just the composition of two functions. Remember, f of g, like fog. And they're saying do not let f of x be x, and do not let g of x equal to x either. Because if you let that be one of the functions, right, it's going to make it really too simple of a problem. So we can have a few different answers for each of these. So let's look at least one or two. Okay, so we know that f is on the outside and g of x is the input. So one thing to do is just to look here and see, well, what is happening? We have a square root, we have a sign, we have a +1, and we have x squared, right? So one thing to do would be to say, well, if g of x was everything in the middle, f of x could just be to take the square root of it, right? So we can say, well, what if, what if f of x is equal to the square root of x, and g of x is equal to sine of x squared plus 1, right? Because then h of x, this is just checking then, h of x is equal to then f of g of x, which is just f of sine of x squared plus 1, which is just going to plug into our f of x this whole input, the square root of sine of x squared plus 1. So that works out. These work. Another possibility would be to say, well, let f of x equal to x squared. I mean, not x squared. Let f of x equal to the square root of sine of x plus 1, right? And then we can say, well, let g of x equal to, I should put a comma there, to x squared. Okay? Then let's check this. H of x is equal to f of g of x. G of x, so it's just f of x squared, right? If we go ahead and plug in to f, here's our function f, x squared, this is going to be the square root of sine of x squared plus 1, which again works out. So you'll see there's a variety of answers that you can look at. You can go ahead and check your answers. So these are just two examples for part A. For part B, so here we're given h of x, and this is equal to 3x cubed minus 12 squared plus 2. And again, there can be a variety of answers. Okay, so let's look at least a couple of them. So what's going on? I can go ahead and say, if g of x is this, right, then I can say f of x can be something squared, x squared plus 2. And that would make g of x be 3x cubed minus 12, right? I can go ahead and check this answer by saying, well, h of x is then the composition, f of g, which is f of g of x. And that's just f with the input of 3x cubed minus 12. I'm copying g. So plugging into f, 3x cubed minus 12, I get 3x cubed minus 12 squared plus 2. Okay, so that checks out to be a working answer. Let's look at a different possibility, right? I can say, well, what if this whole thing was g? Then I could say, if f of x is just x plus 2, right? I'm just adding 2. Then I could say g of x can be 3x cubed minus 12 squared, right? And I can check this easily by just saying, well, what is h of x then? That's f of g of x, which is right here, well, f of this thing, 3x cubed minus 12 squared. And if I plug this into x, I get 3x cubed minus 12 squared plus 2. Again, that's the original h of x that we want, so this is another possible answer. And again, there are a variety of answers for each of these, A and B, and this is just a couple of possible solutions. So that ends for us CPM Calculus Chapter 4, number 49.